Okay, here we go with section 5.3. What we're going to be dealing with now are what we call special angles, okay, in a full 360 degrees. So if we're looking at a full rotation here, there are a few situations that involve or require what we call special or exact values, okay? And the first one we're going to look at here are what we call quadrantal angles. And what that basically means is that your terminal arm is on the axis here, boom, boom, boom. So it can be either at 90 degrees, it could be at 0 degrees, 90 degrees, 180 degrees, 270 degrees, or 360 degrees. Okay, so if you want, you can get back to 360 degrees, but that's essentially 0, right? And if you want to talk about it in radians, it's 0, pi over 2, pi, 3 pi over 2, or 2 pi, right? You get back to 2 pi. So these are the equivalencies here. And what we're looking at is what happens as you go around here. So remember that if you have a unit circle here, one of the important things here to realize is that your sine, let's put theta in here, right? Your sine theta is equal to y over 1, or just y. And your cos theta is equal to x over 1, which is just x. And I guess we can look at our tan as being y over x. Okay, these three things are what apply here to a unit circle. Okay, now don't forget that this is what we call a unit circle. Okay, because it's got a unit of 1, so 1, 0, 0, 1, negative 1, 0, 0, negative 1. Now what happens here, guys, is that if your theta is 0, boom, it's sitting here on the x-axis. And if your theta is 90, boom, it's sitting up here, which means that you're on the y-axis. And similarly back here, and then back down here, okay? So what I want to show you, let me quickly show you here something that maybe I can make this a little simpler for you. What we're looking at then is the value of sine 0. Okay, sine 0. So you can imagine if you go down here, sine 0, your y value is 0. Y value is 0. So sine would be 0. Okay, what about if you're at sine pi over 2? Pi over 2. Well, you can see as this goes up over here, right, your x is getting smaller and smaller and smaller, and your y is getting bigger and bigger and bigger. You get to the point where your x is 0. Your x is 0, but your y now is 1. So here at pi over 2, it's 1. And then you can see as you go back down here, boom, your y is getting smaller again until it hits 0. And then your y again is getting bigger until you get down to the bottom where it's negative 1. We're looking at the y value. As it starts here, it's at 0. Up here, the y value is 1. Over here, the y value is 0. Down here, the y value is negative 1. Over here, the y value is 0 again. Okay? Now we look at the cos function. Cos 0. Well, we can see that the x value here is 1, right? The x is 1. The y is 0. So cos x, or cos 0, would be 1. Then it goes to 0. As the x value gets smaller and smaller and smaller and smaller, it becomes 0 up here, and then it gets bigger and bigger and bigger and bigger. As you come around to this side, it becomes negative 1, and then it goes back down to 0. Okay, and if we look at the tan function here, the tan of 0 is y over x. So if my y is 0 and my x is 1, right, then 0 over 1 is equal to 0. And at pi over 2, it's y over x, right? Your y over x. So this is going to be 1 over 0, which you can't do. And if you actually do 1 divided by 0 on your calculator, you get an error message, okay? It doesn't work. Divide by 0, no worky. So this is what we call undefined. And then you'll notice it goes back down to 0, and then it's undefined there again, okay? So these are our quadrantal angles. And what I want you to see as well is the reciprocal. So the reciprocal of 0, well, that would be undefined. The reciprocal of 1 is 1. The reciprocal of 0 is undefined. The reciprocal of 1 is 1. Reciprocal of 0 is undefined. The reciprocal of 1 over 0 is 0. Right? Okay. So the reciprocal of 0 is undefined. You can't divide by 0. The reciprocal of -1, -1. The reciprocal of 0, undefined. You can't do it. You're going to get an error message. And here we have the reciprocal of -1 is -1. The reciprocal of 0 is undefined. And the reciprocal, this would end up being 1 over 0 like here. So 0 over 1 becomes 0. Those will become a little bit clearer when we start dealing with the graphs of these functions, but right now we're going to leave it at that. Remember that these values repeat in every quadrant, okay? They repeat in every quadrant, and this is why the reference angle is so important, okay? That reference angle is always very, very important. The distance from the terminal arm to the x-axis, or the terminal arm to the x-axis, the reference angle, right? And notice that also as we go around, all that changes is the sign, right? The sign changes. So we go from 1 to -1, or from +1 to -1, -1 to +1. It repeats in each quadrant, right? We're going to look at that a little bit more in detail as well. Remember this ASTC thing, meaning that they're all positive in the first quadrant, that sine is positive in the second, the tan is positive in the third, and the cosine is positive in the fourth, okay? So the next step that we're going to look at here is what we call a 30, 60, 90 degree triangle, okay? This is another special angle. If you thought about the angles that would be special in a circle, right? Let's look at a circle first. The divisions that you would likely use would be, say, the 90s, right? And the 180, and the 270, and the 360, and the 0. That's what we just looked at, okay? Now, what would also be important maybe is this one here, the 45 degree one, right? And then maybe we'll look at a 30 degree one and a 60 degree one. And also their occurrences in the other quadrants as well, okay? These are the ones that we're going to be looking at. All the special angles, so all the multiples of 30, the multiples of 60, and the multiples of 45. I'm going to try and show you why these equilateral triangles, or why these special triangles are of significant, how they work out, okay? So at 30, 60, 90, if you can think about it, it's basically an equilateral triangle is where we got it from, okay? And we can call these 5, 5, 5. If they're all the same, then we can pick any number we want. And what we're going to try and do is find the lowest common ratio. So we can start with saying 2, 2, and 2. Or you could say 1, 1, and 1. But what I want to look at now is half of this triangle. Okay, so that means that I'm going to break this down into 1 here, which means that I want to make 1 and 1. So it seems like this is the lowest ratio. You could call this a half, you could call it, and then these are 1, you could call this 3, and then these are 6. But this is kind of the ratio that it ends up looking like. And what I wanted to show you was that we end up with this triangle right here, right? Where this is the 1, like half of the base, right? And this is 2, and if you did Pythagoras, you'd find out that this is √3. And then from here, what we do is we look at the sine and the cosine and the tangent of both 30 and 60 degrees. I have a tendency to write it like this. I have a tendency to write it like, like this. I usually do it in this way, right? Where this is my x-axis, so this is 30 degrees, and I label it 1, 2, √3. And then we start looking at sine 30, at cos 30, at tan 30. Okay, and then you can look at the other one here as well, when you make it 60 degrees. Okay, so that's 60 degrees, and that would be 1, 2, √3. So I have a tendency to look at both of these, but understand that they're the same triangle. They're this one here, just rotated differently. And now you can look at sine 30. The exact value of sine 30 is 1/2. The exact value of cos 30 is √3 over 2. And the exact value of tan 30 is 1 over √3. Okay, and then this is what we would expect to do. Now notice that we also have the radian measure here as well. Okay, so now sine 60 would be √3 over 2. Notice that cos 30 and sine 30 are the same. Cos 60 and sine 30 will also be the same, right? Cos 60 is 1/2, and tan 60 is √3 over 1. All right, and now we're going to look at the reciprocal function. So if sine 30 is 1/2, cosecant 30 is 2/1. Secant 30 would be the reciprocal of that, 2 over √3, and then root 3 over 1 would be the cotangent. Similarly, the sine of 60 is root 3 over 2. The cosecant of 60 is 2 over root 3. The secant of 60 is 2 over 1. And the cotangent of 60 is 1 over root 3. One thing I want to bring up here are some things that, for example, say I have 1 over root 3. Remember we talked about rationalizing denominators. You don't like having radicals in the denominator, so we multiply both the top and the bottom by whatever that radical is, and you end up with root 3 over 3. So please understand that those two are the same. Okay, so this is a 30, 60, 90 triangle, and these are the exact values that you're going to need to be able to get for 30 and for 60. Okay, now we also looked at a 45-degree triangle, and what I want to show you from this 45-degree triangle is that we can get exact values. Now 45 is kind of makes 45, 45, 90 makes an isosceles right triangle, right? Which means that these sides are the same. So again, let's just give them the lowest number that we can. They can be anything, but let's choose 1 and 1 because that's going to be the reduced ratio when we start looking at the trig functions. Okay, and if you do Pythagoras here, you'll realize that this is root 2. And that's basically what we're looking at, is this special triangle. So now, find all these trig ratios of that special triangle, right? So sine 45 is 1 over root 2. Okay, now think about what we just talked about with rationalizing. Let me write it bigger so that we can show you 1 over root 2, right? So if you multiply the bottom by root 2 and the top by root 2, you end up with root 2 over 2. So that's sine 45. Cos 45 is going to be the same thing. Okay, root 2 over 2. Or if you prefer to see it, you can go 1 over root 2, which is equal to root 2 over 2. Tan 45 is opposite over adjacent, so it's just 1. And then cosecant, reciprocal of that. So how about root 2 over 1, or simply root 2? Secant 45, same thing. It's going to be root 2. And the reciprocal of cotangent, the reciprocal of 1, is just 1. So here we have, ladies and gentlemen, your special angle triangles. Okay? And the types of questions that you're going to get are going to involve these specific values. So let's have a look here and see if you can answer these questions. Boy, I had them somewhere around here, but I don't have them anymore. So what I suggest you do pretty much at all times when you're dealing with these special angle triangles is draw these two things. Okay, draw them both. The 30, 60, 90 and the 45, 45, 90. Okay, 45, 30, 60, 90. And get used to understanding where the numbers go. Okay, these are obviously both 1 to the shortest length. You do Pythagoras, that's root 2. The shortest length is 1, that's twice as big, again, and then that's root 3. So now you can get the exact value for any value. So find exact value for sine 120 degrees. So what we do is you find out where 120 degrees is, and you look for your reference angle. So 120 is up here, okay? And you can see that if this is 180, that's 120. The reference angle is 60, right? So what's sine 60? Sine 60 is root 3 over 2. So sine 120 is equal to root 3 over 2. That's basically it. And then we're looking at the sine. All sine, tan, cos. Sine is positive, so we leave it positive. Boom. Right? There you go. How about cos 330, right? Where's that one? Well, cos 330, that's got to be over here. It's in the 4th quadrant, right? If this is 360 and this is 330, hopefully you can see this is a 30-degree reference angle, right? So let's put our numbers in there. 1, 2, root 3, right? And what's cos of this angle? Root 3 over 2. Root 3 over 2. All sine, tan, cos, it's actually positive as well. What we're doing is we're picking some easy questions here, okay? How about we try something a little bit harder? How about I say sine of 5 pi over 4? Well, let's put that on here. Sine of 5 pi over 4. Where's that, right? Okay, well, let's check it out. That's 1 pi over 4, 2, 3, 4, 5 pi over 4. Okay, and this is pi. So hopefully you can see that this is pi over 4. Your reference angle is pi over 4, right? So that's 1, 1, and root 2. It's a 45 triangle. So sine of this is 1 over root 2. 1 over root 2. Check out your sines, all sine, tan, cos. Tan is the only one that's positive here. So down here your sine has to be negative. We don't like necessarily the radical in the bottom, so we can go negative root 2 over 2. All right, and it's the same thing over and over and over. The only thing we're going to be looking at that's a little bit different is, say we look at cotangent. Okay, let's do a couple things here. Cotangent of 13 pi over 3. What the hell is that, 13 pi over 3? Well, we know that there's got to be a coterminal angle, so we got to figure out where that is, right? Over 3. So a full rotation is 2 pi, right? If you want to put that in thirds, it's going to be 6 pi over 3, right? So 6 pi over 3 is back here, so this is 2 pi, sorry. So this is 0, and then it's also 6 pi over 3, and then it's 12 pi over 3, and so where would 13 pi over 3 be? It's just another third pi, so it's going to be up here, right? Third pi. This is pi over 3 would be your reference angle. So you're looking at a 60, 30, 60, 90 triangle. Short side, long side, root 3. And then what was the cotangent of this number? So what would tan of pi over 3 be? Well, tan of pi over 3 is root 3 over 1. So cotangent would be 1 over root 3. All sine, tan, cos. All, it's up in here, so it's positive. We don't want the radical in the bottom. We can multiply the top and the bottom by root 3, and you end up with this. Holy macaroni, hey, ladies and gentlemen. So this is essentially what we're going to be looking at. Sometimes you might be given a question that looks like, you know what, I'm going to leave it there for now. Any questions that you guys have, please bring them to class. These are the triangles that you're going to be dealing with. Get very used to writing them down so that you can use them in most of these questions. Hope that helped. Have a nice day.